Alright, this video kind of completes the thought that we started in the last video. We looked at multiplying monomials there. Here we're going to flip it a little bit, look at dividing monomials. Again, we will get more complicated in future videos as we look at dealing with polynomials. But again, we're going to just start with the easy one, start with monomials. Okay, so again, we're going to look at two different methods. The first one being algebra tiles. These are helpful to kind of visualize a pretty abstract concept. We'll do that, and then we'll see that perhaps there's a way as you get the hang of it to go a little bit faster by just using some algebraic techniques. Okay, so method one, using algebra tiles. In order to visualize this, in order to be able to grasp this concept, we need to recognize that a division statement is really just a multiplication statement that's juggled around a little bit. So, for example, if you take 3 times 2 equals 6, we could juggle that around a little bit and say that 6 divided by 3 is equal to 2. See, there's parts that are interchangeable once you switch them around. Right? So this means that a division statement can be modeled in the same way as a multiplication one using algebra tiles. It just switches a little bit what parts go where. So the numerator in a division statement, remember the numerator is the top number, that becomes what we refer to as the area of the rectangle that we're drawing out, and then the denominator becomes one of the dimensions, either the length or the width. Now the quotient, or the answer, then becomes the other dimension. So let me show you what I mean. If we have our little grid here, okay, and we have our statement of negative 10x squared, we're going to divide that by 2x. We said that the numerator, so the negative 10x squared part, becomes the area of the rectangle, or the part that's drawn out. If you remember back to our last video, we started with both dimensions and we filled it in. We're going to work backwards now. We're going to start with the numerator being the part that's already filled in and go from there. So negative 10x squared, we need to arrange these negative 10 of them. We need to arrange them in a way that is a rectangle. And it can't just be any rectangle. It needs to be a rectangle that has one of the dimensions be the denominator. Okay, so I have the denominator was 2x, so I'll put that in as one of the dimensions, and you see that that works out. I get a rectangle there with negative 10 or 10 negative x squared tiles. And one of the dimensions is a positive 2x. Now, I've got to think, what happens when we take a negative and divide it by a positive? What sign, or what is it going to be, positive or negative, the other dimension? Well, if we end up with, or if we begin with a negative and we're dividing by a positive, the numbers along the top are going to be negative, and we just fill it in. They must have been negative x tiles. Okay, and just to be sure, we can review and work backwards. We can see that a negative 5x that I just drew in there, multiplied by that positive 2x that we had before, does indeed equal that negative 10x squared, so therefore we did it right. The answer to this would be the negative 5x that I drew along the top. Okay, let's do another example, make sure that we've got it. So again, you draw out your grid, and we come up with a way to draw out our numerator, negative 14x squared, in a rectangle that includes the negative 2x as one of the dimensions. So the negative 2x will go there. Basically, I need to stagger them in 2 groups. So I'm going to do that, draw them out. I need to have 14 of them. There's 8, 9, 10, 11, 12, 13, and 14. Okay, in order to make that work, if I have a negative divided by a negative number, that means that the answer must be positive, so I fill them in, and you'll see that I'm going to need 7 positive x tiles along the top in order to get out to that other dimension there. So the answer would be positive 7x. Okay, so you can see makes sense, it works. It is a little bit time consuming and takes a bunch of paper, so let's see if we can do it in a different method as well. Okay, that's using algebra. Very simply, again, all you got to do is divide the coefficients. Okay, start with that, then you deal with the variables, and again, those variables, you need to deal with them. Make sure that you're following those exponent laws that we looked at in Chapter 2. Again, if you need to recap on those, go back and watch those videos. We'll kind of talk through them as we answer these couple of examples. So the the coefficients here, we've got 18 and 3, so we divide out the coefficients. 18 divided by 3 is 6. X squared divided by x. Remember our rule for dividing variables that have a common base is simply subtracting the exponents. So we have a 2 as an exponent on the top. There's a little unwritten 1 there on the denominator, so we have a 2 minus 1, or just 1 left. So very simply our answer is 6x. Okay, divide coefficients, divide variables, you're left with 6x. Show you another example here. Okay, we've got coefficients of negative 18.6 divided by negative 3. Okay, so 18.6 divided by 3 is going to be 6.2. We look at the signs. Negative divided by negative is in fact a positive. Good. Then we've got m times n divided by n. Well, the n's cancel off, which means that we're just left with the m. So our overall answer is going to be 6.2 m. Okay, that's dividing monomials. I think once you do a few of those, that's going to work out good. You'll understand that quite well.